The design of a plastic injection tool is a multi-step process. It begins with the actual concept of the plastic part design and goes to the mold designer to model the cavities and cores that will be the actual steel that forms the tool. The design of the tool on the computer involves modeling all the components necessary to form the completed mold. After the components are modeled in the IDEAS software system, they can then be brought into the machining software where the tool path can actually be programmed to cut the specific mold detail. Once the NC program is generated from the software and loaded onto the machine tool, the program can then be ran and the tool movements be performed by the machine in the process of actually removing the metal to form the core cavity of the mold. After that process, we then went to the graphite electrode to EDM, or electric discharge machining, the contour that we want into the mold cavity. After the mold construction is completed, it becomes the mold operator's responsibility to process the tool correctly for the specific plastic that will be ran in the tool.
This is a plastics processing lab in the materials technology labs at Lexmark. And what we have here is a Nisi 40-ton injection molding press. This is a rather small machine, and the 40 tons refers to the amount of pressure that it can hold on its mold to keep it closed. What you do with an injection molding machine is basically make plastic parts. You can make virtually anything, any type of plastic part out of these. It could be an inkjet cartridge or a printer cover, or it could be a plastic plate or a plastic fork. But anyways, how you work these type of machines is you use material such as this here. This is a plastic resin. It's just granulated plastic, and this particular one has some red coloring in it. But you would take this plastic, such as this, and put it in the top of the machine up here in the hopper. As you put it in, it goes down and is fed down into the throat of our barrel of this injection molding machine. That material is then fed down through the barrel by a screw and is pressurized with shear pressure, or shear forces, and there are also heater bands along that barrel. The heater bands and the shear force melt that material and make it into a liquid or a molten plastic. That plastic is then pressurized and is squirted through the nozzle of this machine out into the mold, which is over here on the clamping unit. As I said, this is a 40-ton machine. That means it's using 40 tons to hold that mold together. Once that mold is brought together and then the molten plastic is squirted into it, you make a part. That part cools, and then it is ejected from the mold and it falls down to the bottom. Right now in this mold we're making a Frisbee mold. That's not what we normally make here, but it's a good example for molding. As I said, we might be making tinsel bars, or we might be making printer components here. But right now we're making Frisbees. When they come out, these Frisbees have a runner system on it, which is just the path that the plastic took to get to the Frisbee. And when you're done, you just cut the runner off and you end up with a Frisbee.